Okay, so let's see, that last video, we left off with these, the last thing we did were these two right here. So let's just finish this up and let's get these bottom ones done. Okay, so let's see. All right, so this is 5 and 6. Okay, so let's see. Again, I would multiply coefficient times coefficient, so -1 times -3 is just 3. And then I have x to the 3/2 times x to the 1/6. Okay, so I could add the 3/2 and the 1/6 times y. I have 1/4, okay, times y to the 5/2, so I can add the 1/4 and the 5/2 like this. Okay, so let's see, we have 3x. Okay, so let's see, I gotta add 3/2 and 1/6, so I gotta multiply the 2 by 3, okay, so to get a 6, so I'd have to multiply the 3 by 3, so I'd have 9/6 plus 1/6, so that is 10/6. Y, let's see, I'd have to multiply above and below by 2 here, so I'd have 1/4 plus 5/2 is 1/4 plus 10/4, so that's 1/4 plus 10/4 is 11/4. Okay, so let's see, take a look at that guy, and 11/4 is reduced, but 10/6 is not, so I gotta reduce that. So divide them both by 2, okay, and I would get 5/3. Okay, so x to the 5/3, y to the 11/4, like that. All right, so that would be your answer in exponential form right here. Now, the one thing that's a little different compared to the other ones is notice that both of these exponents are improper fractions, so that means that things aren't in simplest radical form. So you can take a look at it and you say, okay, well, how do we put it in simplest radical form? Well, you could go to root form first if you wanted to, or you could put it in simplest radical form, leaving it in exponential form. That's fine. We could take a look at, let's go to root form, okay, just because we do that most of the time. So let's see, this would be 3 times the cubed root of x to the 5th times the 4th root of y to the 11th. Okay, and notice how it starts to get muddy because the index numbers are different. Okay, so let's see, I need cubed root, so I need x cubed. Okay, so this would be the cubed root of x cubed, but I have a total of 5 factors of x, so that would be times x squared. Okay, times the 4th root. Okay, well, I need y to the 4th, so notice I could go y to the 4th times y to the 4th. I can get 2 of them times y cubed. And 4 plus 4 plus 3 is 11. Okay, so let's see. We have 3. Well, the cubed root of x cubed is just x, so that'd be x times the cubed root of x squared, okay, times, let's see, the 4th root of y to the 4th is y, and the 4th root of y to the 4th is just y, so I'd have y times y on the outside, so I would get y squared times the 4th root of, I'd be left with a y cubed underneath. Okay, and then, you know, we have things that are not part of the radicand, so we can move those guys out front. So I would get 3, I'd have an x, and then I'd have a y squared, okay, and then it'd be times the cubed root of x squared times the 4th root of y cubed. And so you see this guy, and then you see this guy. And clearly this guy is cleaner looking than this guy. So if I was given a choice, do I want to leave it in exponential form or do I want to go to root form, I would stay in exponential form. But if somebody said, hey, you know, you got to put it in root form and you got to have things in simplest radical form, I'd have to go down here. Okay, so let's see what's going on with number 6 here. Okay, so 5 times 1 is just 5, multiplying the coefficients. Okay, I have an x, and so I have x to the 7/3 and x to the 5/6, so I can add those. 7/3 plus 5/6, and then y. I got y to the 1/2 times y to the 3/4, so that would be 1/2 plus 3/4. Okay, and then we can add exponents. Okay, so let's see, 5x. Okay, I'd have to multiply by 2 above and below to change the 7/3 into 6. So 7/3 would become 14/6. So 14/6 plus 5/6 is 19/6. Like that. And then y, let's see, 1/2 plus 3/4, so I'd have to change the 1/2 to 4, so that'd be 2/4 plus 3/4, so that's 5/4. Okay, and so you have your answer in exponential form, but notice again, that's just like this guy over here, okay, where these rational exponents are improper fractions, so they're not in simplest radical form. So if we keep going with this to take a look at it, go back to root form, so I'd get the 6th root of x to the 19th times the 4th root of x to the 5th. Okay, so let's see, 5, okay. Well, notice I'm going to get x to the 18th times x to the 1st. Okay, now why is that x to the 18th important? Because 18 is divisible by 6, the index number. So x to the 18th times x to the 1st times the 4th root of, well, I need x to the 4th at the very least, so I'd have x to the 4th, I'm sorry, that's a y, isn't it? That's a y here. Why do I have x? Okay, that's a y. My fault, guys. Y to the 4th times y to the 1st. Okay, so let's see what we got. We got the 5. Well, the 6th root of x to the 18th, we just go 18 divided by 6, we get 3, so you get x cubed. And then you're left with the 6th root of x to the 1st, which is just x. Okay, then the 4th root of y to the 4th is just y. And then we are left with the 4th root of y to the 1st underneath. And then just like the last one, we take that x cubed and the y, we put it out front with the 5 x cubed y, and we are left with the 6th root of x times the 4th root of y. And so again, you know, you take a look, and clearly this is a little bit cleaner, well, a lot cleaner than this. Okay, so I would go with that answer unless somebody said, hey, no, you got to put it in root form and present it in simplest radical form, and I'd have to keep going to come up with this guy. Okay, so let's see, that wraps that guy up. And let's take a look at what's going on here. Okay, and notice in all of these you have some negative exponents. Okay, and we don't like negative exponents in mathematics. Okay, we like positive exponents. So very first thing I'm going to do is get rid of the negative exponent. So remember, you're just dealing with reciprocals. So this guy is just the reciprocal of 48 to the 1/2. Okay, so I just drop it from the numerator down to the denominator. So this is just 1 over 48 to the 1/2 power. And then I go about my business. So let's see, that is 1 over the square root of 48. And the largest factor of 48 that's a perfect square is 16. So this is 1 over the square root of 16 times 3. So I just get 1 over 4 radical 3. And of course, that square root, that radical is down in the denominator, so we have to rationalize. So we multiply above and below. Since it's square root, I just need one more factor of that square root to get rid of it. Okay, so let's see, we would get 1 times the square root of 3, which is the square root of 3. And down below, square root of 3 times square root of 3 is just 3, so I get 4 times 3, which is 12. And that guy's reduced. And so there's your final answer in root form. Okay, so let's take this second one. Well, 20 to the negative 1/2 is just the reciprocal of 20 to the 1/2. So we get 200 to the 1/2, not 20. Okay, so 1 over 200 to the 1/2. Okay, so this is just 1 over the square root of 200. And the largest factor of 200 that's a perfect square is 100. So I have 1 over the square root of 100 times 2. Okay, and the square root of 100 obviously is 10, so we're going to get 1 over 10 radical 2. And again, since we're dealing with square roots, when I rationalize, I just need one more factor of that square root. So multiply above and below by square root of 2. So up above, 1 times the square root of 2 is obviously just the square root of 2. And then down below, square root of 2 times square root of 2 is 2, so I get 10 times 2, or 20. Okay, and we're done with that guy. So those top two are pretty simple, pretty straightforward. Okay, so let's see what's going on here. Okay, now notice we're starting to work with things that are not square roots, they're cubed roots and fourth roots, so things get a little bit tougher. Okay, so 54 to the negative 1/3 power is just a reciprocal of 54 to the 1/3 power, so we get rid of the negative exponent by putting 54 to the 1/3 down below. Okay, so this is 1 over the cubed root of 54. All right, now the largest factor of 54 that is a perfect cube is 27. 54 is 27 times 2, and 27 is 3 cubed. Okay, so I want to write this as 1 over the cubed root of 27 times 2. Okay, so the cubed root of 27 is just 3. So I get 1 over 3 times the cubed root, okay, of 2. All right, now I need to get rid of a cubed root. I need to rationalize that. So I need a total of 3 factors of 2 in the radicand. So I have one of them, which means I need 2 more, like that. So multiply below by that, I got to multiply above by that, like that. Okay, so let's see. So up above I get 1 times that, so that's just the cubed root of 2 squared, which is 4. And then down below I'm going to get the 3. And then let's see, this would be the cubed root of 2 cubed, because 2 to the first times 2 squared is 2 cubed. So the cubed root of 2 cubed is just 2. Okay, and so we just get the cubed root of 4 all over 6, and that's rationalized. Okay, so we're good. So let's go to this next guy. Okay, 162 to the negative 1/4 power, that's the reciprocal of 162 to the 1/4 power. Okay, so that's the 4th root of 162. Now the largest factor of 162 that's a perfect 4th power is 81. Okay, so this would be the 4th root. 162 is 81 times 2. Okay, and 3 to the 4th is 81, so the 4th root of 81 is just 3. Okay, so that's going to be 3 times the 4th root of 2. Okay, now we rationalize. Well, I need the 4th root of 2 to the 4th to rationalize it, so I have one factor of 2, I need 3 more. So I got to multiply by the 4th root of 2 cubed above and below. 4th root of 2 cubed. Okay, so let's see. So 1 times that, so it just gives me the 4th root of 2 to the 3rd power. 2 cubed is 8. That's all it is. And down below I have the 3. And then if I go the 4th root of 2 times the 4th root of 2 cubed, I'd have 2 to the 1st and 2 cubed, so that'd give me a total of 2 to the 4th. So I'd have the 4th root of 2 to the 4th, which is just 2. Okay, so I get the 4th root of 8 all over 6, and I'm done. Okay, let's get these last two here. Let's see, 1, 4, this is 5. Okay, so let's see, 72 to the negative 4/3, that's just a reciprocal, okay, of 72 to the 4/3, so we get 1 over 72 to the 4/3 power. Okay, so let's see, what's going to be the easiest way to do this? Okay, how about we do this? 1 over. Okay, so let's see, that would be the 4th power of the cubed root of 72. Okay, so far so good. So let's see. The largest factor of 72 that's a perfect cube, I'm pretty sure, is 8. Because the cubed root of 8 is just 2. So let's see, we get 1 over the cubed root of 8 times 9. And that's to the 4th. Okay, so we get 1 over. All right, well, the cubed root of 8 is just 2, but that's 2 to the 4th. We have 2 to the 4th, and then we have the cubed root of 9 to the 4th, like that. Okay, so let's see what happens here. All right, well, 2 to the 4th is just 16. Okay, so that's 1 over, I got a 16 there. And then let's see, I have the cubed root of 9 to the 4th power. How about if we do this? We go the cubed root of 3 squared to the 4th power. Now you say, well, why do that? Well, I think it's going to end up helping me out, okay, because 9 obviously is a perfect square. So I've got that 16 down there, and then I take the cubed root. Well, I can bring this 4 underneath, and 3 halves, 3 squared to the 4th power, I can multiply those 2 times 4, and I get 3 to the 8th. Okay, this is going to make my life easier. Okay, so we get 1. I've got that 16. And then let's see, this cubed root. Okay, so how about if I take 3 to the 6th and pull it away? So I'm still left with 3 squared because I have a total of 8 factors of 3. Now, 3 to the 6th, that 6 is divisible by 3. So the cubed root of 3 to the 6th, I could just go 6 divided by 3 and get 2, so I get 3 squared. Okay, so I have 1 over, I got that 16. Let's see, the cubed root of 3 to the 6th would be 3 squared, which is just 9. And then I'm left with the cubed root of 3 squared, which is 9. And that's taken care of. You know what, I'm going to leave it as 3 squared, and there's a reason for that, because it's going to be easier to rationalize. Okay, so let's see, 1 over 16 times 3 squared, so that's 16 times 9. 16 times 9, I get 144. So it's 144, and then I have the cubed root of 3 squared. Now I got to rationalize that. Okay, so I got to multiply by the cubed root, multiply by the cubed root, and say, well, what do I need? Well, I need 3 cubed, and I have 3 squared, so I just need one more factor of 3, like that. Okay, so let's see, up above, we have the cubed root of 3, and then down below, I've got that 144, and then when I do the cubed root of 3 squared times the cubed root of 3, I get the cubed root of 3 cubed. So that's just 3. Okay, so we get the cubed root of 3 all over 144 times 3, and that is 432. Okay, so we're good with that guy. All right, let's see what we get on this next one. I might need a little bit more space. Okay, so let's see, we started off the last one. Okay, so that is 1 over 80 to the 3/4 power. Okay, that's good. All right, so let's see, let's go 1 over, let's go the 4th root of 80, and that's all to the 3rd power. Okay, so let's see, the largest factor of 80 that's a perfect 4th power, I'm pretty sure is 16, because 80 is 16 times 5, yep. Okay, so we get 1 over the 4th root of 16 times 5. Okay, so the 4th root of 16 is just 2, because 2 to the 4th is 16. So we get 1 over the 4th root of 16, like I said, is 2 times the 4th root of 5. And now we got to rationalize. Okay, so I've got to multiply by 4th root, multiply by 4th root. Well, I need the 4th root of 5 to the 4th. So I have 5 to the 1st, so I need 3 more of them. 3 more factors of 5. Okay, so let's see. Up above, I'm going to have the 4th root of 5 to the 3rd power, and 5 to the 3rd power is 125. Okay, then down below, I've got the 2, and here I would have the 4th root of 5 times the 4th root of 5 to the 3rd, which would give me the 4th root of 5 to the 4th, so that's just 5. Okay, so we get the 4th root of 125 all over 2 times 5, which is 10. And we are done. Okay, that wraps it up for videos.